So students, today we will start chapter polynomial. So a polynomial is an expression that consists of constant terms, variables and exponents. And its mathematical form can be given as this. So here you can see that an minus 1, an minus 2, a2, a1, a0, all these are constant, whereas x to the power n, x to the power n minus 1, x to the power n minus 2, or you can simply say the term like having x, these are the variables. Now here also you can see the example, that is 3x square plus 2x minus 8. So here in this you will see the highest power of the variable, that is x. So you can see here that's 2. So here in 3x square plus 2x minus 8, you will see that the highest power of x is 2. So that means the degree of this equation will be 2, and this term is having like 3 terms we have in this equation. So it is trinomial, polynomial, trinomial having a degree 2. And you will see that the coefficient of x square is just 3, coefficient of x is 2, and the constant term is minus 8. So identifying the constant is also very important in this chapter. I'm just giving you one more example. Let's say we have 5x square minus 3x plus 4. So here you will see the coefficient of x is 5. So you can say coefficient of x is a. So a is 5, b is minus 3. So you have to remember that if the coefficient is coming with the positive sign, you don't have to write the positive. But if it's with negative sign, you have to write the negative sign as well. Now let's see the degree of polynomials. So here, if a polynomial is given by px, so here you say a is the polynomial, then no variables there, so the degree will be 0. No x is there, so degree is 0. And the example of linear, the x is having degree 1. So if the degree is 1, the equation or the polynomial is said to be linear. If the degree is 2, so here you see that a x square you have, so that means the degree of x is 2. So the polynomial is quadratic. And if it's 3, then it is cubic. So you just have to see the highest one. So you will see here in this equation, you have ax cube plus ax square plus ax plus b. So you have to just see the maximum or the highest power of x. So that's the degree. So if 3, it's cubic. If it's 4, then it is said biquadratic. And if it's more than 4, then you can say it's polynomial. Now the next thing is the value of a polynomial. So you can give the value of a polynomial. Let's say you have an equation px or py equals to x plus a. And you have to find out the value of this polynomial at 2. So you just simply put the value of x as 2, and you will get the polynomial's value. This also you have to use in many exercise, like many sums. Then there is a 0 of a polynomial. If any value, like let's say we are putting x equals to k, and that is giving you 0. So we will say that k is 0 of that polynomial. Now let's see the graphs of the polynomials. So if the polynomial is of degree 1, so the graph will be linear. So as you can see in here, so this can be a graph for equation which is linear. So here if you'll see that equation of this will be something like this. Or x plus 5y equals to 15. So if you'll represent this, so you'll get this equation. And the graph of the quadratic equation, quadratic polynomial, is parabolic. So we will also see one very important topic for this chapter, that is relation between zeros and the coefficients of a polynomial. So let's say we have an equation in the form of ax square plus bx plus c. This is our equation, and alpha and beta are the roots. roots of this equation, or you can also say zeros of this equation. Now what is the zero and the root? So I have already told you. So let's say this is your px. So if you will put alpha over in this equation, so you will get 0, and if you will put beta also, you will get the result as 0. I'll just give you an example as well. So let's say we have a px equals to x square minus 1. So if you'll put x equals to 1, so you'll get 1 square minus 1, so that will give you 0. And same way, if you'll put minus 1, so here also minus 1 square will be 1 only, so that will give you 0. So in both the cases we are getting 0. That means 1 and minus 1 are the roots or zeros of this polynomial px. So now this is very important for this chapter, the relation between the zeros and the coefficient of a polynomial. So let's say you have the equation ax square plus bx plus c and the roots which are alpha plus beta, alpha and beta. So sum of the roots is given by minus b by a, where you can see what is b. The coefficient of x is b and the coefficient of x square is a. So minus b by a will give you this result. Okay, so you can also check this in this example. So here you'll see that alpha and beta is plus 1 and minus 1. So minus 1 and plus 1 will give you 0, and that you can check with the coefficient also. So here you will see for this equation, my a is 1, coefficient of x square is 1. There is no term having x, so that means the coefficient of b will be 0, and c will be, you can see the constant term, it's minus 1. So now I'll check it here also. So you'll see my b is 0, so 0 by 0 will give you the result 0. So here you can see that is equals to minus b by a. Now I'll just show it to you for alpha into beta. So the product of the roots is given with the formula c by a, where c is the constant term over here and a, it's the coefficient of x square. So here also we'll check for this question. So alpha is minus 1 and beta is 1, so that is the root. So that will give you minus 1, and that you can see your c is minus 1, so that is minus 1 by 1. So that is the same as c by a. So here you can see this is also we have verified. So you just have to remember this, and this sum of the roots is minus b by a and the product of the root is c by a. And you can also derive the equation, like you can get the equation if you know the sum of the roots and the product of the root also. So for finding that, you have an easy formula, that is alpha x square minus alpha plus beta sum of the roots into x plus alpha into beta. So this is the equation. So you can also write it as x square minus sum of roots into x plus product of roots. You can also write here zeros in the place of roots. So that's the formula for finding the equation.